Hello students, today we'll learn about association rules and one of the algorithm known as a priori. So this association rule is an unsupervised learning method in which some of the rules are formed which are very much compatible and useful in the expected results. This is a descriptive, not a predictive method, used to discover interesting relationships hidden in a large data set. Here are some of the possible questions that association rules can answer. Generally, these association rules are favored to be used in the market where we will have to check which products will be purchased by the customer frequently. So this association rule is able to answer the questions like which products tend to be purchased together. So whenever we go to a shopping, that time we'll purchase some of the items together. Whenever we purchase milk, then if we purchase sugar, then we'll say that these two items will be purchased together. What products do they tend to buy? Generally, it is the understanding of the shopkeeper. He will understand the behavior of the customer, and according to that, he will try to set its sell to increase the sales ratio of every month or year. Next question is, what other similar products do they tend to view or purchase? So whenever we go to a supermarket, then we'll find some of the items which will be kept in a particular location so that a customer can see the items properly, and because this particular thing can be done by understanding the mentality or the purchasing trend of the customers. So these kind of things can be answered by using the association rule, and it will definitely help to increase the sale of a supermarket or a shop. So this can be considered as a market bucket analysis strategy. If we look at this, there are some transaction bills available here. So these, if we understand or study these transaction bills, then we can very easily analyze the rules. Certainly, we can study the things because we have very few items purchased here on all these bills. So it is very easier to understand that whenever a cereal is purchased, a milk is also purchased, and probability of purchasing milk whenever a cereal is purchased, it is 90%. If a bread is purchased, along with that milk is also purchased, and probability of that is 40%. Whenever a milk is purchased and with that a cereal is purchased, the probability of that is 23%. According to that, we can find the rules, and likewise we can set up a sell of the shop with that particular manner. It will definitely help to increase the sale. Here, if we keep a cereal and milk all together for the sale, so it will be easier for the customer to purchase both the things together. Sometimes it will help the customers to purchase both the things, because if he forget to purchase a milk even though he purchased a cereal, so he will definitely tend to purchase both the items together. So if we understood the market bucket analysis and able to form a very small rules, but this will be more difficult if we have a larger amount of items. In the previous example, we are having a very small transaction details and very few items which are purchased from a supermarket. So we will try to define few things in a mathematical form. So items, we will say that our items will be referred as collection of items or individual entities that contain some kind of relationship. Item is the product that we purchase or a combination of product that we purchase from the supermarket. An item can be defined in the set like item 1, item 2, item 3 and so on, which is a k number of items are defined in a particular set. In this particular set, we want to say that a particular item has been purchased multiple times, or it has got a good support of a purchase. So that we will say if an item L is purchased from a supermarket, then we will have to define an entity that is support of L. That is how many, what is the frequency that L is purchased from the supermarket. The percentage of transaction for if we want to define support, we'll say the percentage of transaction that contains L. For example, we'll say that if 80% of the transaction contains the item set bread, bread is like L, L is some entity. So we say that a bread is purchased from a supermarket, and out of 100, 80% of the time a bread is also purchased. So we'll say that a 0.8 is the support of this particular item known as a bread. So let's say that if 100 people have purchased items from the supermarket, and out of 100, 80 people have purchased a bread. So it means the support of this bread is 80%, that is 0.8. So it means that this particular item has been purchased frequently, regularly. So this is said that a frequent item set. So frequent item set, if one item is purchased, then frequency of purchasing that item is good. But frequent item set, if we have multiple products, for example, a bread and a milk is purchased all together. So we'll say that a frequency of this item set is good, better. So what is this frequency? The often enough. So if we purchase the item often enough, frequently, then we'll say that this particular item has been purchased often, very often, frequently. But this need to have a minimum support criteria. Minimum support criteria is, let's assume that we have set a minimum support criteria is 0.5. Then the item set which are frequently purchased having a frequency more than 50%. What is a 0.5 is a minimum support. We have set a standard. So we'll say that an item which is purchased more than the standard, more than 0.5%, means more than 50%, then this particular item set can be considered as a frequent item set. This is a mathematical details about market bucket analysis. So the attributes we will have to see is support. Support is just now we have seen in the transaction number of data sets. Transaction is the bills that are generated for a person which has bought items from a supermarket. That is one transaction. If 100 people have purchased and the bill is generated, that is 100 transaction has been done. So if we want to find a transaction support for item X and item Y. Item X is, let's assume it's a bread, and Y is milk. So bread and milk, a combination of that, the probability that item X and item Y is brought together is known as a support for these two particular items. The confidence is known that a transaction that contains X also contains Y. So whenever item X is purchased and with this item X, Y is also purchased. So this is known as a confidence. So the probability that whenever item X is purchased, item Y is also purchased. So this is known as a confidence. The association rule is a pattern that states when X occurs, Y occurs. And this is known as for a certain probability. So this probability is matters so whenever we are purchasing item, and this allows us to define the rules for making a association rules. So then how do we calculate a support and confidence? So here n is a number of transaction, total transactions, and out of that are within these transactions how many number of times x and y both are purchased. The total count whenever x and y is purchased, the total count is considered divided by total number of transaction is known as support. Then confidence is the total number of items where X is purchased and the total number of items where X and Y are purchased. So the total count when X and Y are purchased and total count where X is purchased. So this is for calculating a confidence. But we know support allows us to find out a frequent item set, but confidence allows us to identify the increasing interesting rules from all the candidate rules. So we will say that both the items are purchased together, but we know that if X is purchased together, then Y is purchased together. So sometimes we have seen in the advertisement that the items are sold, like if you buy a 4 number of soaps, then you will get a pen free. So this association is defined because we know that this soap and pen is frequently purchased, so that a pen is, if we allow or if we provide a pen as a free, then it's a very certain that a customer is going to buy the soaps because he is going to get a pen, because he wanted to buy pen whenever he buy a soap. So this allows us to define a higher confidence that indicates the rule in more interesting or more trustworthy. So this allows us to define the cell in a very proper manner or with a very confidence building with the help of the support and confidence. So we will define few more attributes. One is a lift. Lift measures how many number of times more often X and Y occurs together. So generally X and Y are purchased together, but it is expected some of the times X and Y are separately purchased together than expected if they are statistically independent of each other. When they are separated, how many number of times they are purchased. When they are together, how many number of times they are purchased. Then we have leverage, another attribute. This leverage allows us to measure the difference in the probability of X and Y appearing together in the data set compared to what would be the expected if X and Y were statistically independent. So these two attributes are also used whenever for generating the association rules. So we will have an example as an a priori algorithm, which is a subset of association rules. So this a priori algorithm takes a bottom-up iterative approach. So we will go from bottom to top. So in the first stage, we'll start calculating the single items and then we combine them all together and then try to find the frequency of 2 item set, then 3 item set, and then more. The 1 item set and then identifying which among of them are frequent. Then the algorithm identifies and retains those item set that minimum support is available. First of all, we'll find a single item set, and if the single item set allows us or has a more frequency to appear in the transaction, then we'll select them and then combine them for two item sets. The item sets which do not satisfy a minimum support criteria, then we'll remove the item sets. Because if the item set is not frequently bought, then we'll just remove it because it is not satisfying the minimum support criteria. Minimum this many number of times the item has to be purchased. If we have defined this particular rule, then the item set which are not satisfying the criteria, we'll remove it. Again, evaluate the identify. So we will see this particular algorithm in the graphical way. So let's say that we have items like A, B, C and D. It may be a bread, milk, sugar, or tea powder, something like this. So these are the frequent item set available. So out of this we found that this A is not being purchased regularly, frequently. Then we'll remove it. We'll go for B, C and D only. Then we'll combine them, B, C. We'll check whether this item B and C are bought together, whether this B and D are bought together, or C and D are bought together. So we want to check the frequency of that. So out of this, we have found these many combinations if we combine them all. But since B, C and D are frequently bought, so we'll go with this B, C and D. If we found these BC, BD and CD are purchased all together, we'll combine them together like BCD and we'll check the frequency, whether these items are bought together or not. If yes, then we'll go for checking further. This is how we have to work with the a priori algorithm. But we need to understand the property of a priori algorithm. It says that if the item set is considered frequent, then any subset of the frequent item set must also be frequent. This is referred as a priori property or downward closure property. So this is an example. If item set BCD is this, if it is frequent means BCD, these three items are regularly purchased, then BC, BD and CD are also regularly purchased. It means a subset of this, subset of BCD is BC, BD and CD. Subset of BC is BC. So if these three items are purchased frequently, then it is very obvious that BC, BD and CD are also purchased regularly. So that B, C and D are also purchased regularly. So it means subset of a frequent item set is also frequent. This is a downward closure property. This is a priori algorithm. So in this a priori algorithm, we have transaction T, a set of transaction that has been done in the supermarket. So this has 1,000 lakhs number of transactions available. So these transactions will hold the candidates, the how many number of items it has, bread, sugar, butter, etc. So it will find out how many candidates it has. So single candidate A, B, C, D. So according to that, it will find the frequency of all the candidates, frequency. So the frequency will be found, and if the minimum number of support is less, then those will be removed. So K is a number of set. So now we will go for a larger two number of sets, two number of candidates like bread and butter together and milk and sugar together. So likewise A and B transactions together, candidates together, item sets together. So this candidate generation, so A, B, B, C, C, D, these kind of transactions, candidate generation will be done. Then the transactions, so it will go through the transaction and for the candidates for finding out the number of, how many number of times every candidate is present in the transaction. So that will be counted. So this count helps us to find out the combination of these transactions is larger than the minimum support, then we will use it. And this frequency will be used for generating a new table, the final rule that can be defined. So we'll try to understand the a priori algorithm with a simpler method. First step is determine the support of items. Determine the support of the items in the transactional database and select the minimum support and confidence. First step is to go through the transaction table available, whatever database available to you, you go through that, find out a number of items and the frequency of that. Second step is to take all the supports in the transaction with a higher support. Higher support means more than the a defined value, more than the minimum support value. If the item set which are less than a minimum support value, remove those and take only those which are with a good support. Third, find out the rules of those subset that have higher confidence. Now once we found the item set which are very frequent, then we will apply a confidence on that and generate the rules. And the final is sort them properly with the help of confidence so that we can take only those which has a good confidence. We will move further and try to understand the a priori algorithm with the help of example. This is a data set. This is a transaction set. This is a TID, transaction ID. T1, transaction T1 means one person has purchased item A and item B from a supermarket. Another person or another transaction which has purchased B and D together. Then transaction 3 purchased B and C. 4, 5, 6, 7 and the respective items purchased from the supermarket. So this is a complete data set available provided to us. In addition to this, minimum support 2 and minimum confidence 50% is also provided. By using this, we have to apply a step 1. What step 1 says? Find out from this particular transaction table, we can understand how many items are available, A, B, then C, and then D, and then we have E. So we'll write all the items A, B, C, D, and E. So we have done. Then we'll find out the frequency of all the items. A is available in transaction 1, then here in T4, then T5, then T7, then T8, then 9. It means 1, 2, 3, 4, 5, 6. So 6 times the A item has been purchased. So the count of this particular item is 6. Then B item is purchased 1, 2, 3, 4, 5, 6 and 7 times. So support count of B is 7. So similarly C is purchased 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5 and 6. So sorry, so by mistake, so it has been written 5 but it is 6. Then D is purchased 2 times and E is purchased 1 time, just here in transaction 8. So we will have a support count here. So this particular candidate set is generated and we have to check it with the minimum support of 2. So for checking with minimum support 2, so we have to check, so minimum support 2 is 0.5. So if we calculate the minimum support, then we can understand that this particular item is not available, not as per the requirement. So this is removed because this does not support the minimum support 2 criteria. So that's why this is removed. Then After removing this, we will get the next level or next item set. So we have to work on this. Then in step 2, we have a transaction table available. This has been borrowed from step 1. Now we have item set A, B, C and D. E is removed because E is not available, or this is not a frequent item set, so we don't need it. So then the next step, in the step 2, what we do is we will generate a combination A and B all together. Now 2 item set. Now we know A, B, C, D. A single item set has been very nicely purchased, frequently purchased. So let's check the combination AB, AC, AD, AB, AC, AD. Then BC, BD, BC, BD and then CD. So this is a combination. So let's check combination. AB is purchased. How many times AB is purchased? AB is purchased here 1. AB is purchased here 2. AB is purchased here 3 and then 4. So 4 is the support count. AC is purchased. How many times AC is purchased? A and C 1, then 2, then 3 and then 4 here. So this is how we will calculate AC. Then AD, BC and BD and then CD. CD is not purchased together. That's why the support count is 0. So this is how we can remove the item set which is not purchased frequently with the help of minimum support, and will go to the further step. So this is what we have borrowed from, we have in step 2, and we know that this particular item set is not bought frequently, so this is removed. This is known as pruning step, removing which is not frequently bought together, or the item set which has a less support than a minimum is removed. So in step 3, so we have we know that in step 2 we have worked with A, B, C, D, these 4 items with a combination. Now let's go for a combination of 3, A, B and C. So if we check A, B and C in the data set, item set, we will understand only 2 times the A, B, C has been purchased together. B, C, D is purchased 1 time. A, C, D is purchased 0 time, and so as A, B, D is also purchased 0 time. So from this table, a subset has been calculated for 3 item set, and the support count is verified in the item set table, the original table. And with this we found that only one combination, this is the only combination which satisfies the support count. There is only one combination of the item set that has support count equal to the minimum support, that is 2. So this is step 3, finding out a more number of item set. So if this is not the end, we can go for 4 frequent item set, 5 frequent item set, 6 frequent item set. But if the more number of tables has been generated, then we are allowed to go further, like 4, 5, 6, 7 item set. Now, once we found that 3 item set, we know that only A, B and C, only these 3 item sets are frequently bought. Create a new table with the possible rules that occurred in combination of A, B, C. Now we are at step 4. What step 4 says? Find the combination of A, B and C. What are the combinations? When A and B are bought together, then C is also bought together. When B and C are bought together, then A is bought together. So the combination is A and C is brought together, B is brought together. So this is how we will generate the rules. All the rules will generate, and we'll check the confidence of that. Now the confidence of when A and B is brought together, C is brought together, this will be calculated the support of A, B and C, whereas support of A and B, that is 2 by 4 is equal to 0.5 is 50%. When item B and C is brought together, it means support of B and C and A. When B and C is brought together, A is also brought together. So the addition, the combination of these three, whereas support of these two will allow us to generate the confidence. Two times A, B, C and A are brought together, whereas B and C are brought together 4 times. So it will calculate 0.5, it means 50%. But for A and C is brought together, whereas B is brought together, this will allow us 50% again. C is this is C. This is a new combination again. This combination allows C is purchased, whereas A and B is also purchased. So this will generate a 2 by 5, that is 0.4%, and this is 40%. So whereas these three combination will generate 33.33 and 28%. So this is less than, we have provided the minimum threshold of a confidence is 50%. So if we apply this 50%, so it says that these three are supported rules. These are not supported rules. So we have to remove these, because these three are not in use, because these three do not support the confidence. So whereas these three rules will allow us to generate more confidence to apply in the supermarket. So if we apply these, or if we keep these items together, definitely the sale of the supermarket will increase. Next. So this is how we have learned the a priori algorithm, and we can definitely apply it into the supermarket to increase the sale. There are few advantages and limitations. We can say, we don't say that disadvantage, we'll say that limitations of a priori algorithms. So these are, this is easy to understand. This is a very easy algorithm. We just need to find out the frequency of single item set, then 2 item set, then 3 item set, and then 4 item set. In between these, will have to apply a pruning method, that is removing the non-frequent item set, and we can very easily implement this. Then join and prove steps of the algorithm can be easily implemented for a larger data set. It doesn't matter how many item sets are available in the data set. We can just keep applying this and this a priori algorithm, and it will work. Then there are few disadvantages available with this a priori algorithm. The algorithm works slow compared to the other item sets. See, the first time we'll apply a single item set, then we'll go for 2 item set, then 3 item set. So this is a slower process, very slow. It will take lots of time. If we have a large number of item sets in the data set, so it takes time to scan every item set from the data set. Overall, the performance can be reduced as it scans the data set for multiple times. So we have a data set, we have to scan it for a single time when we are checking the frequency of single item set. We'll go again and check the item set for 2 item sets. Again, we have to go in the memory and scan the complete data set. If we are checking for a frequency of 3 item set, again go to the data set and check the frequency to check the frequency of 3 item set. This is how we have to go multiple times to the database, and the performance is reduced, and that is why we say that this is very slow. The time complexity is also very high. It needs a huge amount of space as far as space complexity is required, because the data set is huge and we have to scan it, and again the single item set data set, then 2 item data set, so it increases eventually. So thank you for today's discussion, and we'll come back and do more discussion on forthcoming topics. Thank you.